When I approach a writer, or in other words, a Euclidean geometry problem, I've organized the theorems into 4 parts for me to, especially for the moments where I'm stuck, where I'm not sure how to move forward. So, firstly, if the question mentions there being the center of the circle, then they tell you that this point is the center of the circle, I immediately think of this relationship where you have a circle and you have a chord and a line passing through the center, a perpendicular line passing through the center of the circle, which will then bisect that chord. And of course, those conditions can be swapped around. So they might tell you that there's a line passing through the center of the circle and it bisects a chord, in which case you know that that line and the chord are perpendicular. Or they might tell you that there's a line perpendicular to the chord and it bisects that chord, in which case you know that that line must pass through the center of the circle. So when I hear center of circle, one of the relationships that I think about is this guy, right? Another important relationship I think about is angle at center. So angle at center is twice angle at the circumference. So I look at what angles, so maybe for a particular angle I'm looking into, ask myself, okay, is it at angle at the center? If it is, which chord is subtending it? And what other angles does the same chord subtend at the circumference? Then I know I found an angle at center relationship. And kind of related to that, if I have a center, then I might have a diameter. So look out for diameters and whether those diameters are subtending angles at the circumference, because then you know it's a 90-degree angle. So that's this relationship over here. And then, of course, very importantly, if you have the center of a circle, then you also potentially have radii. So look for any lines that are starting at the center and ending at the circumference, because then you know you have a radius. And once you have a couple of radii, what's common is that those radii will form part of an isosceles triangle. So those are the things that come to mind for me when a question mentions the center of the circle. Sometimes cyclic quads will be explicitly pointed out to you, but sometimes you will need to identify them for yourself. So before even launching into a question, I would start by identifying, are there any cyclic quads, and just highlight them for myself, so that if I get stuck, I can kind of think, well, is there anything that the cyclic quads give me? Of course, cyclic quads give you two relationships. The opposite interior angles are supplementary, they add up to 180, and the exterior angle, or an exterior angle of a cyclic quad, will always be equal to the opposite interior one, right? And then tangents. So tangents, the question will explicitly tell you such and such a line is a tangent to the circle at such and such a point. And these are the relationships to keep in mind when that information is given to you. So try and see if you have any radii that are connecting to the tangent, because then you know you have a perpendicular relationship. Or if you have two tangents and they're meeting at an external point, then you know that they're equal in length from the point of contact to the point of intersection, right? And of course, our beloved tan chord. So look for this relationship, like be intentional about looking for, okay, there's tangent. Are there any chords connected to the tangent? In our case, there's this chord and there's that chord. So this angle will be equal to the, how do we say it? The angle, I don't know, something about an alternate segment. But anyway, this angle will be equal to this guy, and this angle will be equal to that guy. So look for tan chord relationships intentionally. And then these are two relationships to always look out for, no matter what information you're given. So angles in the same segment, look at, okay, so for instance, you look at, maybe they've given you the size of this angle. So you ask yourself, well, which chord is subtending it? And we see that it's coming from this chord. And then you say, well, what other angles is this chord subtending? Whether at the center, if they've told you about the center of the circle, but also at a different point at the circumference, because then you know that these angles will be the same size. This relationship doesn't come up as often as the other ones, but it's also a good one to know, that if you have two equal chords in the circle and they each subtend an angle at the circumference, then those angles will be equal. So that's also one to just kind of keep in your back pocket, because now and again, the surprise attack with that one.